Hello everyone. Looking at day 2 now of our unit 6 of quadratic equations. Only a couple days away from finishing quadratics. Hold on to that. Up until now we've been solving quadratics. We've done factoring, partial factoring, completing the square, and traditionally students are asking for this at one point. And I know some of you have used it already within your work, as you may have older siblings or someone that's shown you. And today we're going to be looking at situations where we can't factor because it's not possible, and then we have to use an alternative method. Well, let's start with a warm-up. So it says example 1, solve 2x squared plus 4x minus 10. Okay, that graph right there to the right is the graph corresponding to the equation, so we can check our answer at the end. But when it says solve, we just need to simply factor. Okay, so let's go ahead and do that. Well, in order to factor, we need to come up with our little t-chart. And what multiplies to a times c, which is 2 times negative 10, negative 20, and adds to positive 4, sorry. Let's go through this together though. Okay, so all of our factors of 20, well, you have 1 and 20. There's no combination that you can put together to add to positive 4. You have 2 and 10, 2 times 10. You can't get the sum of 4. And then you have 4 times 5. And again, you can't get the sum of 4 no matter what combination of positive and negative you use. This problem here, when we're approached and we look at all the factors and we recognize that nothing works, it's unfactorable. We can't factor it. But it doesn't mean that we don't have solutions to it, because if you look at the graph to our right, you notice that there are, in fact, 2 zeros or 2 roots in this equation. So what we need to do is find an alternative way to kind of use those things. When it's unfactorable, what we do use is the famous quadratic formula. So the roots of a quadratic equation in standard form. So in order to use a quadratic formula, you must have a quadratic in standard form, because standard form gives us an a, a b, and a c value, and that's what you will see you will be substituting into this large equation is a, b, and c. So you can determine those things. Some things to keep in mind when you're using the quadratic formula is that you are more than likely going to get decimals or fraction answers at the end. If you're working with application problems in decimals, I'd recommend that you always keep 2 decimal places in your answer. And it's also helpful if you figure out a way to use your calculator that you can do it kind of all in one step after you substitute it. That way you're not having to rewrite decimals. Okay, so let's go through an example here, and it is a very intimidating formula because it's new to you. However, it's just a matter of substituting in values and making sure that you take your time and follow order of operations. So I want to make a couple notes first. So when a quadratic is not factorable, use the quadratic formula. Okay, I wouldn't get in the habit. You can use the quadratic formula in a situation where a quadratic is factorable. However, I wouldn't recommend it. More students make mistakes in the quadratic formula than they do with factoring. Factoring, you can kind of check your answers and go back and expand. Quadratic formula, it doesn't work that way. Okay, so I'm just going to rewrite the equation that we had up top. That was 2x squared plus 4x minus 10 equals 0. Okay, again, when we're using quadratic formula, we have to make sure that one side of our equation is equal to 0 so that we can plug in those values. Okay, I'm going to rewrite the quadratic formula. So it is negative b, and should include that negative, plus and minus, so both of those operations, the square root of b squared minus 4ac divided by 2a. Okay, it helps, I think, if you on the side here identify your a, your b, and your c values as a means of keeping the right sign. So our a value here, it is 2. Our b value is 4. And our c value is negative 10. What we want to do is plug all of those values in now. Okay, well, we're going to have the negative, we're going to substitute in 4 for b, plus or minus, b as we just found is 4, a is 2, and c is negative 10. 2, and then we substitute in 2. Now, once you get the hang of it, you can do this all in one step if you like, but for the first few examples, I'm going to go through and break apart step by step so we can see where all these values are going for. But what we want to see in your work is that you, one, can give us the quadratic formula, so you will have to memorize that, and 2, can you substitute the values in the right spot, and then 3, ultimately, can you get the right answer by using the formula properly. What you want to do here is kind of think of this in 3 steps. So you have 1, you have this negative 4 out front. You have everything under your square root sign, and then you have what you in the denominator of this formula. Solve each of those pieces of information separately and avoid doing anything after that. So, well, if you look at this first part, negative and then in brackets 4, this is just going to become negative 4. Plus or minus, okay, well, 4 squared is 16. And then we have minus 4 times 2 times negative 10. Well, let's look at that as a whole. It's all multiplication. You can do it in a row. 4 times 2, that's 8. Times 10, that's times negative 10, that's negative 80. Okay, make sure your signs there are important. And then 2 times 2 is 4. I'm going to simplify what I have under my radical square root sign there. 16 subtract negative 80 is the same as saying 16 plus 80, which gives me 96. And we still have that 4 in the denominator. This is where I would recommend you split our equation into 2 separate parts, and where this plus minus is going to come into play. Okay, so we're going to have our first value of x, because up until now we have had everything have 2 solutions, and it's going to be negative 4 plus the square root of 96 divided by 4. And my second would be negative 4 subtract the square root of 96 divided by 4. So we have to do both of those operations, negative 4 plus 96 divided by 4, negative 4 subtract, and that's why I separate at this point, and that's how we're going to get our x1 and our x2. Okay, so do that separately. Negative 4 on your calculator plus the square root of 96 divided by 4 should give you 1.45 if you round to 2 decimal places. Negative 4 subtract 96, or square root of 96, divided by 4 is negative 3.45. Okay, and I told you that that graph that we started with is in fact correct, and it goes with this equation. So let's look at our solutions, our values of x, negative 3.45 and 1.45, and see if we are right based on our graph. Okay, well, this looks like it's about 1.45, and this is about negative 3.45. So those are correct. And that was your first experience in using the quadratic formula. Again, you can do it in less steps if you want to kind of simplify and solve everything that I have highlighted here in yellow. In one step, that's fine, but it's completely about your comfort level. So let's do a couple more examples here involving the quadratic formula so we can get the hang of it with each other. Okay, and determine the roots of each equation. So roots referring to those values of x that we're looking for. Everything is already rearranged here for us. Again, I'd recommend that you start these problems by identifying what is a, that is 3, what is b, that is 15, and what is c, which is negative 7. Okay, let's see, without looking up on your page or scrolling up, what is the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Substitute all of your values in. Okay, well, this is 15 plus or minus 15 squared minus 4 times our a value of 3 and our c value of -7, and divided by 2 times 3. Okay, now I'm going to simplify everything we have here in one step. Okay, so this becomes -15 out front, plus or minus. If I do this all the math underneath my radical square root sign, 15 squared is 225, subtract the product of 4 times 3 times -7, which gives me 309 divided by 6. Okay, again, we're going to branch off into two values. This one is going to be -15 plus the square root of 309, and the second one is going to be -15 subtract the square root of 309 divided by 6. Now pause the video and just do that on your own, and then check here in a few seconds if you got the correct answers. As you see, x1 is 0.43 and x2 is -5.43. Another way you can check your answers is take that equation and graph it on some sort of software program such as Desmos, and then just highlight over the cursors where the roots are to see if these two values are in fact the roots. Okay, moving on to the next example. We can see that here we have to do a little bit of rearranging. So we just need to bring here, this side now becomes equal to 0. We have 2x squared minus x minus 9. And I always like to rearrange things so that I have my highest exponent first, and it just is in decreasing order after that. Again, let's identify what is a. That's 2, b is -1, and c is -9. See if you can come up with the quadratic formula on your own. So there's the quadratic formula. Hope you are starting to memorize each of those parts. Plug in each of the values you see. Okay, well, our b is -1. So you plug that in two spots. Minus 4 times 2 times -9, and divided, sorry, this should be extended over all of it, 2 times 2. Okay, well here, this is the first time we had a negative b value included. Negative times a negative results in a positive number. So if you're substituting in a negative b value, this leading constant is going to become positive. And the rest of it, -1 squared is 1, subtract 4 times 2 times -9 would be the same as saying subtract -72. 1 subtract -72 is the same as saying 1 plus 72, which gives us 73 divided by 4. And now that we have that simplified, we can go and branch off to our x1 would be 1 plus the square root of 73 divided by 4. And our second value of x would be 1 minus the square root of 73 divided by 4. Again, see if you can come up with those solutions by yourself. Pause the video and check in a few seconds. If you see here, our x1 value is 2.39, x2 is -1.89. Just check to see if you got those right. Okay, one last example, and as you see here, there's only going to be one difference, is that this has some expanding and some rearranging to do. So don't even think about the quadratic formula just yet. So what we need to do is distributive property here, and here we also need to expand the 2x plus 3 squared and write it out as 2x plus 3 times 2x plus 3. So I'll first do the distributive property. Negative x times x, negative x squared. It's negative 2x. And I'm going to write this out the long way. Now, when we have two binomials like we do right here, recalling what we can do is we can use FOIL, or distributive property of binomials. If you use FOIL, what you're going to get is your first term, so that's 2x times 2x, which is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x, and 3 times 3 is 9. You're just going to want to combine your like terms. Okay, and now that we've kind of gotten rid of our brackets through expanding and FOIL, we're going to have to rearrange our problem so that we have one side of our equation equal to 0 and all of our constants and variables on the other. So consistent, 4x squared, I'm going to bring that other x squared over. I have plus 12x, that 2x is now going to be on this side and still plus 9. Our resulting equation is 4x squared. Okay, or no, sorry, that's not right. 4x squared plus x squared is 5x squared. 12x plus 2x is 14x. And then we have plus 9. What you want to do now is take those values. Well, we have a is equal to 5. We have b equal to 14. And c is equal to 9. Plug those into the quadratic formula and see if you can get to that final step where we branch off into solving for our x1 and our x2. So take a few minutes, write down the quadratic formula, substitute your values in, and see if you can come up with that. If you go through the quadratic formula, you're going to get to a point in this problem where you get here. Okay, so I could simplify this a bit further, right? So I'm going to go negative 14, and then I'm just going to simplify under my radical. 196 minus 180 gives me 16, and we still have the 10 there. When we branch off, we still have our x1, we still have our x2. This is negative 14 plus, this would be negative 14 minus. Now what I notice here is 16, I'm looking at the square root of 16, and normally I would carry that into the next step to avoid decimals. However, I know the square root of 16 to be 4, so we can just do that right here and no longer have to deal with that radical sign. It might be a little easier in the problem here. So now we're left with negative 14 plus 4 divided by 10, which is negative 1. So some of you can do that in your head. And negative 14 minus 4 over 10 is negative 18 over 10, which is reduced to negative 9 over 5, or if you want to see it as a decimal, is negative 1.8. Okay, that is the quadratic formula. It really requires some practice in substituting these values in, so please try and do that. Try these suggested exercises on page 343 to 344, and let us know if you have any questions. Awesome. Bye-bye.